We're now looking at 7b.3. Our MLO is I can write the ratio for sine, cosine, and tangent using the Pythagorean theorem to calculate the missing side. So now we're just combining the two things we've already learned. We're still finding sine, cosine, and tangent, but now we're going to have to use Pythagorean theorem to help us find the sine, cosine, and tangent. So let's look at our first example. Example 1 is find the cosine of angle A. I am going to start by writing SOHCAHTOA up top, right? Sine is opposite over hypotenuse. Cosine is A over H. Tangent is opposite over adjacent. Okay, so I have SOHCAHTOA. Then, my first question is find the cosine of angle A. So, finding my, labeling my sides. Right, here's my right angle. Opposite that is my hypotenuse. And finding the cosine of angle A. Opposite of that. Right? And then between the angle and the right angle is my adjacent side. Okay. So if I'm finding the cosine of A, the cosine of my angle A, right? Cosine is adjacent over hypotenuse. My adjacent side is 8. And my hypotenuse is 10. And then that reduces to 4 over 5. That's it. Looking at example 2. Now I want to find the sine of angle A. So I'm going to start by labeling my sides. Opposite from my hypotenuse, opposite from my right angle is my hypotenuse, right? The same triangle, so opposite from my angle A is my opposite side, and then between the two is my adjacent side. So finding the sine of angle A. Sine of A, well, if I'm using sine, it's opposite over hypotenuse. My opposite side is, oh wait, I don't know my opposite side. I do know that my hypotenuse is 10. Okay. So this is where we run into trouble. I don't know what my opposite side is because, right, it's missing. So I need to find my opposite side. This is where my Pythagorean theorem comes in, okay? We have C and then A and B. Okay, don't get confused with all the letters, right? Pythagorean theorem uses A, B, and C, and our sine ratios use O, A, and H, okay? So I usually just go hypotenuse is C, A I just keep as A, and O is B, okay? So now I have to use my Pythagorean theorem. A squared plus B squared equals C squared to find that missing side. So A is 8 squared, B I don't know, C is 10. 8 squared is 64, plus B squared equals 10 squared is 100. 64 and 100 are on opposite sides, so I'm going to subtract 64. Those go away. B squared equals 100 minus 64, we get 36. And I'm going to take the square root. So B equals 6. Now that I know what B is, right, it's 6 over 10, which reduces to 3 over 5. Right, so this 6 that we found here just goes into my missing side there. All right, let's look at a few more examples like this. Example 3, find the cosine of A. I'm going to start by, this is where my right angle is. It's not drawn in for you. I apologize about that. Right. Across from our right angle, though, that's our hypotenuse. Then we are once again finding cosine of angle A. Across from angle A is our opposite side. And then between the angle is our adjacent side. Okay. So we are finding cosine. So cosine of A. I'll write it here. All right, if I'm using SOHCAHTOA, right? Cosine is adjacent over hypotenuse. My adjacent side is 5. My hypotenuse doesn't have a number. That's supposed to be a question mark. Ran out of room. There we go. All right, I don't know what that is. So that's what I'm going to look for using Pythagorean's theorem. So A we'll just keep as my A, B, and C. So we have A squared plus B squared equals C squared. A is 5. Right, B is 12. C I don't know, so we'll just keep it as C squared. 5 squared is 25. 12 squared is 144. 25 plus 144, we get 169. And then, again, just take the square root. The square root of 169 is 13. Okay. And then, right, whatever number I find goes into my question mark. So I have 5 over 13. Looking at example 4. Same thing. Find the tangent of angle A. Start with, here's my right angle. Across from that is my hypotenuse. I am finding the tangent of angle A. So, right, there's a theta there. That's fine. That's the angle we're given. Across from that is my opposite. And then between the two is my adjacent. So I am finding tangent. Tangent is opposite over adjacent. So the tangent of A equals opposite over adjacent. My opposite, right, is the side that I don't know. Just a question mark. My adjacent side, right, is 6. Okay. So since I have a question mark, I need to find my missing side using Pythagorean's theorem. So again, A is just going to stay as A, B, and hypotenuse is always your C. So again, my Pythagorean theorem, A squared plus B squared equals C squared. A is 6. B squared, we don't know. C is 9 squared. 6 squared is 36. Again, can't square B, so we just leave it as B squared. 9 squared is 81. I'm going to subtract 36 from both sides. So I'm left with B squared equals 81 minus 36. We get 45, I believe. Oop, open the wrong thing. 45, yes. Okay. Then I need to take the square root. So B equals, again, if I typed in the square root of 45, right, we get a bad number. So I'm just going to leave it as the square root of 45. And just like before, that number then replaces our question mark. All right, we have 2 more questions we're quickly going to look at. All right, example number 5 says, given tangent of theta equals 5/12, find sine of theta. Okay. For these problems, I'm always going to start by just drawing myself a nice triangle to look at with my right angle, and I'm going to put my theta somewhere, so that other angle somewhere. So then it tells us tangent of theta equals 5/12. And again, remember, we're still using SOHCAHTOA. We're going to be using it in everything we do. So tangent of theta equals 5/12, and tangent is opposite over adjacent. So all that means is my 5 matches up with my opposite. So my opposite side equals 5. And 12 matches up with A. Right? 12 and A match up. So my adjacent side equals 12. Okay? So in my triangle, right, from what I now know, I don't know my hypotenuse. I know my opposite side is 5. And I know my adjacent side is 12. And we can even put an equal sign there. All right, so my opposite side is 5 and my adjacent side is 12. So now what am I trying to find? I'm trying to find the sine of theta. Well, sine is opposite over hypotenuse, which equals 5 over, we don't know. So what are we going to do? Same exact thing. Okay, I'm going to use my Pythagorean theorem. So again, A is going to be A, B, and my hypotenuse is always C. So I have A squared plus B squared equals C squared. A is 12, B is 5. I don't know my hypotenuse. I don't know C. 12 squared is 144. 5 squared is 25. 144 plus 25 is 169. This question seems familiar. Taking the square root, C equals 13. Okay. So again, my missing value goes here. Sine of theta is 5/13. So again, this is really just telling you the size of your triangle. All right, let's look at one more example of these ones. Given cosine of theta equals 3/5, find sine of theta. Again, triangle. I'm going to put in my right angle, and then I'm going to put my angle in one of the corners, right, in one of the acute angles. So I can label my sides. I have hypotenuse, my opposite side from my angle, and then the adjacent side between the two. Okay. So I need to know what I know. I have cosine of theta equals 3/5. And again, using SOHCAHTOA on the top of everything, right? Cosine is adjacent over hypotenuse. So that means my adjacent side equals 3, and my hypotenuse equals 5. Okay. So adjacent side is 3, hypotenuse equals 5. So then, what am I finding? I'm finding the sine of theta. Well, sine is opposite over hypotenuse. I don't know my opposite side, but I know my hypotenuse is 5. Let's find our opposite side. So I have an A, I don't know B, but I do know C. So we have A squared plus B squared equals c squared. A squared is 3. I don't know b. C is 5. 3 squared is 9. 5 squared is 25. They're on opposite sides, so I'm subtracting. B squared equals 16. Square root. B equals 4. Goes right into our question mark. That is it. Go ahead, work on your B3 activity.